A very good afternoon to everyone present here. Am I clearly audible?
Yes, Diksha, audible.
All right. I welcome you all to this webinar organized by the Center of Police Technology. Before proceeding further, I would like to give a small introduction about what is Center of Police Technology. So basically, the Center for Police Technology, which is also known as CPT, it serves as a specialized accelerator which is designed to modernize law enforcement through cutting-edge technical integration. It basically acts as a collaborative platform where the police forces, the tech startups, and the global vendors develop field-ready tools for smart policing. From predictive analytics to advanced digital forensics, CPT ensures that officers are equipped with a technological edge to combat modern crime. Its mission is to streamline the deployment of innovative solutions that make policing more efficient, transparent, and proactive. I thank everyone for joining this webinar today, and I also welcome our esteemed speakers. For today, we have Rajesh Patel, sir, who is a cybersecurity engineer manager at IBM, specializing in AI-driven threat detection, intelligent security operations, and cloud-native security architecture. With expertise in generative AI, cybersecurity engineering, and cloud technologies, sir explores how AI can augment human decision making. We have Mr. Dhananjay Chandrasekhar Rokde sir with us. He is an information infrastructure, cybersecurity, and digital business convergence specialist with extensive experience in building and securing large-scale technology ecosystems across industries such as banking, NBFC, manufacturing, retail, and IT services. I also welcome our esteemed speaker, Mr. Bharadwaj DJ, sir, who is a senior architect cybersecurity at Synchron with 16 plus years of experience in application and infrastructure security, threat modeling, vulnerability management, and secure SDLC. He also heads the AI risk management program in risk assessment and control frameworks aligned with NIST and AI frameworks. I am very glad to have you all with us here today. We also have Barun sir, who will be joining us later in the webinar. With this, I would like to invite Drajesh sir, handing over the platform to you, sir.
Thank you, Diksha. Thank you very much. And thank you for having me here today. It is a pleasure to be a part of this group today and to share my thoughts, like what I know, what I understand, probably what I can contribute to the larger ecosystem here. So let me do one thing. Let me share my screen and probably we can start from there. Is it visible?
Yes, sir, it's visible.
Perfect. So the topic for today, when I was asked it, I wanted it to be AI versus AI. Because until now, it has, like, until last year, I'll say, it has been AI on the offensive side and humans plus AI somewhere on the defensive side, right? But however, in the past couple of quarters, the landscape has changed. The battlefield itself has revamped in terms of how things are moving in that direction. And I'll share some insights, share some examples, how it is happening, what is it is happening. Uh, Probably with the introduction, I'll not take much time because I think Tadiksha already mentioned I am an engineering manager with IBM for Curadar SIM. People who understand the SIM world will or might have heard the name of Curadar. I look after the design, delivery, release of the whole product out of India office here. Apart from that, I do a lot of sessions. I have spoken at more than 450 sessions, 1,000 plus mentors, received some awards, wrote some papers. Recently published a book on AI and I, the human side of AI leadership, just a few weeks back, actually. This is about me. If you want to know more, probably do reach out to me and probably we can talk one on one. To begin, right? This is where the new cybersecurity and AI intersection is moving towards. It is an arms race, and everybody of us has seen or witnessed how the AI landscape is changing. For example, today one of the model claims they are at top. At the next hour or the next day, there is somebody else who has claimed that spot. So that landscape is changing pretty drastically, and that is where people want to leverage it. I'll give the recent example of the US Iran Israel war, right? There have been news of how Anthropic or ChatGPT is being used for cyber attacks or finding details, etc. I'll not share details here, but it is changing the whole war landscape, the landscape, and people have to be updated in terms of how we are going there. So earlier it was, I mentioned that it was AI versus human plus AI, but now it is almost AI versus AI. It is here both the attackers and the defenders use AI as weapons, as shields to attack and defend whatever they are trying to do. So that has created an equal opportunity on the attack landscape, attack surface, where it was earlier, it was very difficult for humans to using automations or manual intervention to defend the whole surface area. However, with this, it has almost changed now. It has become 1:1 now. Machine speed operations have increased now because the dwell time has change from days to seconds. People who understand dwell time, whenever there is an intrusion, the time that it takes from the intrusion to that lateral movement or reconnaissance is what we call as dwell time, and it has expanded across every other scenario for the cloud, SaaS, OT, and even AI agents nowadays. So that is the one area. The second area, the third area is data and compute. It is the next firepower because that uses almost as much as power that you might need to fire a rocket probably, or launch a missile. And the ammunition for this is the data quality. We all understand without data, no model can function, no model can give us the output that we want. There are continuous learning loops that decide which is the winner in real time scenarios here. And the last one, the most important one, is governance. uh, Currently what is happening is security is an afterthought. We build something or people build something and then they say let us make it secure. But nowadays, because of this governance practice being come in, the security and privacy by design, SPBD, that we all have heard of, is becoming the very base of the design itself. And that is what is helping it to be secure by design, having us incorporate robust policy frameworks and always having human in the loop for almost critical mission loads. And this is a reality. 2026 is going to be AI versus AI on AI. Almost every bigger enterprise have moved towards that, and some of them who haven't moved, they are already on the path and should be there in the next couple of months probably, I'll say. Now let's start with the first part, the offensive part, right? I have a very good scenario here. A few months back, there was a hospital in the United States. What happened was around 2 o'clock in the night, there was a power trip for just few seconds, and then it came back in. There was nothing identified, nothing went wrong there, and it was all hunky dory. But the next day, because of some intrusion details, how they found there was an intrusion, and because of that, people did try to stop the ventilators, the power supply to the ventilators. So now here, AI or that kind of attack, that scale of attack is possible where it is not harming our financial backbone or our infrastructure, but humans as well. That can cause a human life. And that is where the scope has enhanced because of AI being used very drastically on the offensive side. It has helped them expand their whole attack surface. Now, earlier, whatever used to take them weeks or months happens in minutes or days, and they can run multiple things in parallel. And that is what has also been very critical in the recent breaches that we all have seen. There are a few examples like LLM spear phishing. For example, almost everybody has seen spam emails coming to their inboxes now. Earlier, the ratio was very low. Nowadays, almost many of our emails first land into our inbox where we say this is a spam. Why did the spam filter not recognize it? And that is where the LLMs are spear paced into context aware writing, grammar, almost understand the emotion of how it is has to be sent. That is one thing. The second is deepfake fraud. I think we all heard 2024 Bangkok incident where there was a video call from a CEO. There was everybody on the call, CFOs, the whole C-suite, and the CEO asked the CFO to make some payment of a couple of $1 million to a bank account, and there was no suspicious. Everybody was okay, and the transaction was performed. However, the next day it was found out everybody on the call except the CFO was a deepfake. Everything was happening in real time, and there was a huge monetary loss, huge reputation loss, because of all these deepfakes. I myself was almost there to be attacked. I'll give my real example. I was in my living room one day in the morning having my tea. I get a call from my an unknown number. I pick it up. On the other end, it was a rushed voice, sounded like my wife. And she mentioned on the other side, they mentioned, can you transfer 25,000 rupees to this number urgently? I am stuck somewhere. Now, when we think of it as our family members and loved ones and dear ones, they are stuck somewhere, we don't give it a second thought. We immediately want them to get out of that trouble, and then probably we'll see. However, I just at the next second understood or figured out my wife was upstairs having shower. They were not successful into this, but however, they were almost close. If my wife was out of house, and I would have trusted her, I would have believed it. I might not have transferred money still, but that is another scenario. But this is how it has been happening now. And this investigation led me to how these models are trained. So I'll move, before moving ahead, I'll give you an example. Most of you receive calls, you answer, and nobody on the other side answers. You say hello, कौन बोल रहा है, how क्या बात है, we talk, like, and then it cuts off after a few seconds. However, there are bots calling on the other end, recording our voice samples, and that is what in turn are used to target our near and dear ones using the voice sample. So that is how deep fix. We don't understand the criticality of just answering, like speaking something and it cuts off, but at the behind there are a lot of things happening in parallel there. The third one, I'll come back to this session now. Agentic box, right? There are autonomous agents who are doing reconnaissance, exploiting change, lateral movements. I myself have seen this. I was doing some investigation for somebody, and there was a bot mesh that was constantly hitting a target network, trying to get the data. If one of that is blocked, the next one respawns and does it again. So that was one of the applications of how offensive side are using the bots in those areas. Polymorphic code, rewriting malware is what has been introduced. Everybody has heard of that, and that is what is being introduced by offensive side to make sure they can bypass most of the time and get through the endpoint. And the last one is adversarial ML. So direct attacks on AI models have succeeded nowadays. For example, just a few weeks back, there was somebody who was on one of the LLM models, and they wanted to break through the some Mexican government side, and they were able to get that LLM model to bypass most of things, understand vulnerabilities and bypass those vulnerabilities, and probably get around 30 plus millions of personal information out of that attack itself, just using just bypassing or just manipulating the ML model there itself. And that is pretty norm nowadays. And almost 90% of the autonomous sites that I've observed that are happening today are autonomous now. This is a recent source that we have. This is all about the offensive side now. But if I move to the defensive, like how is defense coping up with this offensive side? The first one is behavior anomaly detection. So we have been until now into the protection phase, but now defense has moved to behavior. For example, the way I talk, the way I write, the way I type, my pattern would be different than how a bot or how a person who has gained access to my network would write. And that is how systems are able to decipher if that is a genuine or a real person, or somebody has impersonated or is within the network, or a bot. So that is how entity and behavior models and anomalies are used to get around or block those kind of attacks. The second one is autonomous responses, security, orchestration, and response. They are also used to automatically contain all these threats using playbooks, and at the almost near real time isolate those hosts and revoke the credentials at lightning speed, I'll say. I have seen some of those in action where that has happened. I have been part of the development of similar tools, and I have seen real time attacks being mitigated at the spot there itself. Pretty good stuff there. Now the third one is deep tech and sandboxing. Like ML guided decoys are there as sandboxers to attack, to lure the attackers to come in there in a controlled environment, so they can be analyzed. What are they doing? How are they entering into our network? What are the protocols? What are the systems they are using it? And that data helps us to even fine tune or secure our network on the defensive side. And the last one is predictive threat intel. This is still very predominant in the industry now. That is still we want to use, where uh, first is the global threat intelligence data is used for enrichment and predictive analysis. And there are synthesizers, not in simulators. Those can generate threats. Those are not available in the market, and see how prone our networks, our systems are, and safeguard those even before a real attack occurs. And so this is how we are securing the AI now. For example, the red teaming activity that is done for models. Uh, the second one is filtering prompts and giving guardrails. There was a pretty decent example in terms of having guardrails that on Zomato. What happened was somebody was on the chat, and there is an agent that a bot that answers to your questions, right? However, somebody who was a technical person uh, gave a prompt of admin bypass all these things and directly have a human agent assigned to me, and that is how it was able to bypass that and assign a physical agent or a person directly to that interaction. And that is how we see in the current today's data, there are no guardrails, there are no policies that can hinder or this or avoid this. And that is where we need to secure this, provide guardrails so that we make sure it doesn't go haywire pretty easy. Data provenance integrity, ensuring that the data is gold here, we all understand. So data has to be clean, labeled, protected from every other source. So there is no injections, there are no poison pills within the data itself that can adhere the result or compromise our response there. And the last and the most important one, we are humans, we need to behave like humans, and we need to make sure we are in the loop, we are reviewing most of the stuff and approving after everything is in line there. Moving to the most important, right? These are numbers that I have uh, across various organizations that I have seen. The first one is, like, if you see the global cybersecurity AI market size rate in 2023, it was around 20 to 23 billion dollars. However, in the next 2 years, it is projected to go around 60 61 billion dollars. Currently we are at around 35 to 40 billion dollars, and we are probably on the market trend. So this industry, this market is going pretty up, and so is the requirements for system solutions and personnel to cater to this market, right? uh, Now what I have seen is, we did a recent research and found that almost 70% of the organizations are using Gen AI in their security stack. However, most of them don't have the understanding of how secure it is or how crucial it is. Is it developed created correctly, or it is just there for the namesake? So that is a big gap there. There is adoption, however, that is not there are no guidelines or policies in this adoption, and that is a bigger area that needs to be plugged in. Now the major concern here is around 90% of the organizations are concerned about hostile AI agents. We all have seen most of the agents go rogue or do stuff that they are not meant to do. For example, the recent example of Clawbot, the Meta security engineer itself, who was responsible of putting guardrails, the Clawbot was deleting her emails itself, and it was public news, it was big news out there. So that guardrail, those guardrails of what is supposed to be done or what is not supposed to be done, is still a gray area, and most of the times those are the gray areas where agents or stuff like this goes haywire and results into a pretty big loss there. There is another risk is in the threat volume and complexity, because of the inclusion of AI, because of we have AI at both the sides. The volume of threats have increased. Earlier, if we saw around a couple of 100,000 attacks per day, now it has moved to hundreds of thousands to millions now. So that volume has also increased, and also the complexity has increased because of easier adoption on the offensive side, uh, everybody has tools, technology stack at their disposal to use and fine tune to their requirements, and be on the bad side to attack any network that they want. Uh, uh, Also, almost 90% of the steps are fully autonomous in terms of where there is AI versus AI on the defensive side. If there is AI, 90% of those steps are automated now in terms of threat mitigation, threat initiation, in terms of rule creation, in terms of flagging, in terms of blocking or adaptation. Everything almost has been automated there. Uh, and that is what has given the defensive side an edge over the offense. Else, it would have created a havoc in today's era, where, for example, even for an India Pakistan match, if there are a couple of million hits to the network of multiple Indian government sites, just imagine the scale that it happens when there is an international event or national event happening. Uh, thus, the numbers speak for themselves. However, what we are missing here is still, I'll say, still 90% plus of attacks happen because of human negligence. We are the weakest link in the whole security chain, in the food chain, the security food chain. For the rest, around 10%, we have systems, we have solutions, we have softwares, we have all these things available that can easily avoid whatever is coming at their door. But because of human negligence, human error, it can be anything, or human greed as well, that goes out and that results into around 90% of the attacks, global attacks that are happening, to be a part of this, right? And almost one security incident, uh, on an average, loses around 4.5 million US dollars. There is a loss of this amount for every, on an average, for every security incident that has happened globally. uh, yes, I think this is all that I am before time. Thank you. And if there are any questions, I can take those. If people want to reach out to me, they can scan this QR code, they can get in touch with me, and probably I would be more than happy to take that conversation ahead if anybody wants. Anybody has any questions? Oh, let me open the chat. Can we get this PPT? I'll share it with the organizers, and if they can share it, I'm okay with that. How can we safeguard our organizations from AI attacks? So at organization level, right? I mentioned the attack surface. So, for example, it starts from your endpoint devices to your servers to your routers to your network devices. It has to start from there first, and also training and sensitizing humans here, because I mentioned my own examples how it works out. I also have an example where one of my colleague received an email from another colleague mentioning, can you confirm or verify this document? That was one email that was hijacked from an outsider, and they were able to just put a payload in there. However, because we are from the security, we were able to identify it and not click anything. However, people get very easily guided towards that and click on those links, anything, and that can create havoc. So you have to start from the very ground up. Now, sensitizing the humans, is very easy. However, people following that is very difficult. Now we cannot force them to follow that, and that is where the bottleneck is. However, if we start sensitizing from people, then it is very 90% of our job is almost done. And then next 10%, we have tools, technologies, methodologies, processes, softwares in place to start that safeguarding. I think I have answered both the questions. If nothing, thank you. I'll give almost 6 minutes back, and the next session can start. Thank you very much.
Thank you so much, sir. You summed it up in a very insightful manner, and I think so the learners would have also enjoyed it. And I think we are done with the questions in the chat box. I think we have few questions in the question answer box. Sir, if you don't mind, can I put them?
Sure. Let me check. Yeah, it is there. Are open source tools sufficient for defensive part? I am using Wazoo as SIM and then Olama based. Yes, open source tools are sufficient. However, you need to use them, plug them in your use case. Depending on the use case, you can even strengthen it more than they are now. I know people, because I am a part of the open source community. I am a huge contributor to the open source community here, and I use a lot of open source tools and technologies here. So yes, you can use it. You can club it with another tools available and make it more secure or to your use case. Amit Patil, org now create their internal AI for various operations. What is the baseline you can suggest? Amit, I was not able to answer your question, but yes, every organization has their own AI for their operations. But I did not understand what is the baseline that you can suggest. Sorry. What are the security tools, endpoint network, cloud production used in industry? So this is also all dependent on the ecosystem that you are a part of. If you are a part of the Microsoft ecosystem or a Google ecosystem or the third party ecosystem, because organizations want to rely on only very few, one or a few tools and technologies, so that they can manage easily, they can work around easily, and they can get the required support. uh, Depending on that ecosystem, you have n number of solutions available for all this security that you mentioned, Surpreet. Harsh Yadav, with AI, people are worried it is going to take job. What can in the cybersecurity do to say? Yeah. So I also mentioned this, right? Jobs are not going; they will be repurposed. They will be rebranded, like how it happened in the internet era or in the mobile app era. A data warehousing engineer became a data engineer recently. So that is how it is going to be. However, we need to make sure, because our job is very critical here. Developers can come and go. The security will still stay, and that is where we make sure whatever understanding, whatever experience we have, we use AI to augment that, use AI to enhance that, and make sure we are on the top of our game. So can just put a force into it. At an AI individual, what steps can we take to get was or force into parting or hard-earned money? It is the difference. So Rajesh, to answer your this, first verify and then trust. This is the framework that everybody needs to use. Like I gave you my example. If somebody calls you saying transfer money, your friend or family members, call them back on their regular or original number that you have. If they answer, if they say everything is good, then it's okay. Also have your way of talking to them, way of have secure passcode with them, or of passphrases with them to verify if they are a genuine person. And that is how you can get creative here. That is how you need to be human. You need to get idea of how you want to verify who you are talking to. Samrat, can you give more practical examples of how to secure the environment, especially when customers have different option of? So, Samrat, when we talk about AI models or strategies, right? Uh, this already comes with a few policies and guardrails that even customers they also have agreed to, and they also have concerns about those. First one is data security. That is one important. There are other compliances: GDPR, DPDP, PII, HIPAA, FDA. Those are all regulations that need to be considered, so that you can also make sure they all follow those compliances. And by default, even if there is some security event, it is all secure. How to deploy offline air-gapped environment like MCP server? Rajiv, that depends on the use case. How do you want it? Where do you want to use it? If it is an air gap and you want to use it from an external environment or internet, then it will be very difficult. Harsh, yes, I'll share it with the share the PPT with the organizers. They'll share it with you. Whether it is safe to allow ALAMA or ILAMA sites, that all depends on the your CISOs or BISOs or CIOs to evaluate your the use case and to allow ALAMA or ILAMA or not. I think thus using open source AI can be reason of data threat. It is open source, so people understand the code there. That is one. However, when you adopt open source code, anything open source, you have to make sure you understand what are you going to use it for, and how are you, if there are any gaps, if there are any boundaries are not blocked, how do we make sure for our own use case, for our own environment, how are we going to block that? That also has to make sure, Abhijit. I think we are on time. I'll hand it over back to Tiksha.
All right. Thank you. Thank you so much, sir.
Sure.
Let's proceed further in the webinar now. But before diving further, I would like you all to understand a little about the Future Crime Research Foundation. So, FCRF is just more than a think tank. It is India's premier non-profit organization, which operates in the field of research, AI policing, and also helps law enforcement, corporates, and citizens to stay ahead of the digital curve. Very few initiatives of FCRF include the first of all, the FCRF Academy, which has launched the landmark and elite programs such as Certified Cyber Crisis Management Professional, Data Protection Officers, 2 batches, Governance Risk Compliance Professional, and the recent Fraud Risk Investigator, which is scheduled to start from 14th March. We are also on the ground with initiatives like CyberSafe Uttar Pradesh and the CSR project in partnership with the Paytm Foundation, driving cybersecurity literacy to every corner of the country. We also have flagship event, the Future Crime Summit, completing the 2 successful editions of it. The third edition is scheduled in August in New Delhi. Starting with the webinar back again, I would like to invite Bharadwaj, sir. Sir, are you there with us?
Now am I audible and visible, Titiksha?
Yes, sir. You're clearly audible and visible.
Thank you. Thank you. Hello, everyone. To start with, I would like to derive something what Brijesh Patel happened to mention during his part of the webinar. While he was explaining the situation where he was almost getting victimized as one of the cybercrime scenarios, he said he got a call from his wife, and the immediate words that followed from Brijesh so naturally is that when we get a call from our loved and dear ones, because it was wife, these words were bound to follow. And he literally depicted the vulnerable situation of all the married men over there. So thanks for that. So with that note, I believe we have a nice mix here. Hardcore tech professionals, tech folks, non-tech leaders, maybe some generalists, and also people from law, cyber law, policy making side of the things as well. So I will try my best to keep my language simple, though the topic of the discussion is a little technical, very much into the code development part. And I'll try to provide some real world examples and impact as how you can connect back and remember something that we are all going to learn together. So if you are from legal, police, governance, or investigations part of the wing, don't worry. I'll keep the examples as practical as possible so that everybody can connect and take the lessons away from this webinar. Right. Having said that, let me share my screen. Titiksha, can you confirm if my, oh, I have a, 1 second, let me pause my video and try this out again. Titiksha, is my screen visible now?
Yes, sir, it's visible.
Visible? Thank you. Thanks for that. Okay, good afternoon, everyone, again, and thanks to FCRF Academy for having me. Quick context, AI is actually writing the code now in almost every team, in every stack possible out there. And the question we all should be answering is, it's no longer will we use it or not. That's a obsolete thing as we speak today. The actual question is, how do we use AI without creating silent threats and vulnerabilities at scale? I lead currently one of the key work that I'm doing with my organization is I'm leading in AI risk management work. So I'm going to keep the talk practical with all the lessons I'm going to learn, because it's not something like I have a decade of experience, because all these AI things came up very recently and I'm also learning through the process. What goes wrong, how it gets exploited, and what controls will actually help the remediation mitigation part. We'll all try to touch upon these things. So the first topic I have is the security risks hidden inside AI generated code. Let's start with this. The uncomfortable truth is AI generated AI generated code, any AI tool which generates the code is definitely confident, but it's not careful. It will produce something that looks very professional, compiles very fast without any compilation runtime error. And now AI is able to pass all the happy path tests that the AI itself has created the tests. It only passes it tests. That's the reality that I'm seeing, at least in my company, in most of the development projects. But with all these things, it can still be very unsafe. Here is the big pattern, because there are three pillars that I have put here. One is threats, the other one is vulnerabilities, the other one is mitigation. Remember, whatever looks correct is not safe, is not necessarily be safe. Because AI does not invent security. AI literally averages out the internet's information. Because it can quietly bring in weak defaults, very old libraries, which we even don't know whether it exists or not, or even the dependencies that you all are popular of incorporating into your code, all those dependencies that might sound very legit, very genuine, but ultimately it should not be trusted. See, the whole scenario is in the police terms, right? Especially the traffic police terms. In most of the cities and even uh, the places of India, villages of India, we see a signboard from the police department. Speed thrills but kills. That is the exact problem we are dealing with AI. It's a thrill. Things happen because even when I look back for some of the tasks that I was doing in my past, which used to take a week's time for coming up with a new proposal strategy or a delivery strategy, application security, VAPT plan or something, which used to take 4 to 5 days of my time. Now I can get it done in 2 hours. That's the speed we have got. And at scale, definitely it is the same cascading effect is there everywhere in all the work that we do. This is the problem because developments move very fast, and these code snippets, code, they spread across services like wildfire. You don't have a control about it, because innovation without trust cannot scale. If all your teams, when I say teams, all the project management people, development or coding people out there, if your teams ship faster but trust collapses later, you actually did not gain any speed there. You actually gained a future incident response work for your company. Maybe you will recruit one more team who will do the IR work. That's what we gained as a team. Because imagine this, when we are, I mean, again, quoting from what happened today with me, I'm bound to cook on every Saturday and Sunday. It's a rule at my home. The same items which my mom or my wife can cook in 15 to 20 minutes with great taste outcomes, I do it for 2 to 3 hours of time. When I try to prepare a vegetarian thali, which I always usually do because that's the easiest and I'm seasoned to do that now. If someone hands you a ready-made this Everest packet, sambar packet, or a powder packet, maybe MTR powder packet, it's a fancy packet in your hand. It smells brilliant for sure. But the moment I got that packet in my hand from my wife or my mother, I do a quick check. What is the expiry? What is the brand that I'm using? They have given me, whether it's tampered or not. What are its ingredients? Don't we all do that? Because the other way around, if the sambar powder or the tikka powder, whatever we are using, if it is home generated, if it is done powdered at home by my wife or mother, I don't have the audacity to even check or ask what are its ingredients and all. So when it comes as a fancy packet, we all check that. That's exactly what we have to do with AI. It comes at scale, it comes at speed, it also comes with a little uncomfortable truth that we are bound to check its ingredients, its expiry, whether it's tampered or not. It's nice aroma, but verifying the ingredients before it goes to production is mandatory. I'm not going to read out all the fancy words, all these hallucinated risky dependencies, insecure patterns. You all can go through this once the PPT is handed over to you. The whole takeaway that I'm trying to have from this slide is the risk is not that AI writes bad code. No, that's not the mindset that we have to approach with. I repeat, the risk is not that AI writes bad code. The risk is AI writes good looking risky code at speed and scale. In the backend, we don't know which dependency it has taken, what is the quality, what is the ingredients. Unless we check it, we are unsure. So that's where I stop on this slide part, because mitigations are very common. By default, have the mindset of untrusting or don't trusting the AI code, AI output. You have to, earlier in the classic development work that we all had done in the past, before the AI era, the SBOM did not matter much. The software bill of materials, right? The ingredients list. But now the AI bomb, AI bill of materials is the most important thing that as humans, we have to check before we push our code or the application packages to the production. And of course, it comes with secret scanning, secure code review gates, a lot of tools over there which can do a fantastic job for you, and you can all use it, right? That's about the security risks hidden inside the AI generated code. It's inside and it is hidden. We are explicitly supposed to go mine it, check it, and then push the things into the production. Moving on. The injection attacks and execution flaws in AI assisted development. That's the topic. So what I mean by this? Think of the flow. Someone gives input. The AI confidently writes a query, because you all can literally use the free version of Gemini or ChatGPT, right? You can prompt, that's the input. AI gives very confident looking code, and we take that. Some people are so naive that they copy paste from that ChatGPT window to their IDEs, maybe Microsoft Visual Studio Code or the IntelliJ, whatever, Eclipse, whatever the IDE that you use, and we run it, right? That's what we do. The danger here is we start treating AI output like the trusted code, as some God-given magical golden stuff in front of, because it comes at ease, right? It comes very fast. It comes at ease. You don't have to do anything. And even I have seen some of the developers in my company, they first copy paste the whole code from the ChatGPT window, and then they try to debug after they run it. If there are any compilation errors, any business logic errors, runtime errors, then they think of it. They don't even read the lines of code given by the AI tools, because we are getting so comfortable. We are kind of losing the cognitive abilities which we had by default earlier. I'm not blaming AI. I'm just saying that's how we are going in this direction. If we do this, that's a trap. We are getting into the trap. Additionally, AI often recreates a lot of patterns it has seen before. That's how the AI works predominantly. Because if the training data contains insecure examples, whatever the AI model that gets trained, if the training data itself has a lot of insecure examples or insecure data in that, it can reproduce them SQL injection, XSS injection, command injection, information disclosure, all the classics, right? All the AppSec classics I'm talking. And the worst part is the code snippet we look, which we think it looks clean, are not clean because we don't even read the code. We copy paste that. We try to run, only look for debugging when the error comes. Otherwise, the code is into the production straight there. In many organizations, I'm telling you, it's not just my organization, which this hallucinated way of coding has started now. In many organizations, the agents or pipelines can take the AI input and execute it fully autonomously. No human in the loop. It just takes the input, writes the code, executes it, and closes the tests. The funny part is the tests are also written by AI only. It is as good as I'm setting the exam paper myself and I'm answering them, I'm evaluating them, and I'm claiming I got 100. That is how the whole pipeline has become now. This is where the execution flaws become the real business risk. Change the context. Don't look always as technical ease of the work. It's about how we can take that and map it to the real business risks. Because attackers don't need to be geniuses. All they want, all the hackers, attackers, everybody want is one place, just one place where untrusted input becomes a trusted execution. Because earlier, gone are those era, folks. Even we are in the AI. AI does not provide answers anymore. It actually takes the action now. That's where we are in. Because if I look back to the same example which I started with, right, preparing thali on my weekends, I wash all the leafy green vegetables, right? We all do. Maybe a cucumber or bendy or lady's finger, whatever it is. If we don't filter or rinse them properly, the mud, the chemicals on those green leafy vegetables, the sand part, it goes into the sabzi or the palya which we prepare, right? And can you imagine taking out all the mud, the sand, or the chemicals, which is part of each and every bite of the sabji that we eat with chapati or with rice? Can you eliminate that at that moment? Very difficult. So, filtering is the most important thing here. Classic example is how you do with the application security, filter out all the things, encode, what is that? The inputs, this, all those sanitization things, all those comes into picture now. So some of the fundamentals from the clean coding, secure coding methodologies from the classic conventional coding still applies to the AI assisted development work also. The bottom line is never let AI become the shortest path from user input to the production execution. Always have enough controls, enough checks, enough scanning, and your human operated model of checking the things in place. Then only let it go to the production. Right? This is not about possibility. These are the real world, real day-to-day basis examples and the things that I have quoted here. It's happening on the ground. Moving on. Now we come to the most real world slide in my 4 slides of the PPT. Let's be honest. Let's not blame attackers, because when we talk in cybersecurity conferences or we read some of the fancy blogs of cybersecurity, right? They always mention attackers break in. No, attackers just log in. They don't break in, man. We are the ones who give the keys to them. They log in. That's all. What is that break in? Unless we create enough configuration flaws, we as humans, developers, project managers, I'm talking about all of us, right? unless we are not capable of ensuring our own application or our own platform has at least the rudimentary minimal security things taken care. Saying attackers are breaking in is more of a news headlines. That's all. That gets you good TRP, not the actual solution. Because in AI assisted development, authentication failures happen because people copy the snippets, which I gave as examples from the chat windows. Some of them actually contain some of the AWS tokens, Azure keys, or quick authentication workarounds. It is AI generated, right? Unless you read and understand what the code is getting generated by AI, it contains a lot of sensitive information. And if the AI tool is already embedded in your ecosystem, in your company's landscape, right? It can actually give something which your peer is using, because it's all about configuration problems. See, we were not prepared to handle this sudden burst of or the surge of the speed coding and stuff like that. You may have some keys or tokens in the code given by AI tools, which your friend had actually generated in the past, and you are using the same thing, right? Generated code by AI, whatever it is generated, that works, but assumes too much privilege also. Whatever is all the zero trust policy, uh, the policy of minimal or the least privilege concepts, everything should be used. But AI cannot, because it does not understand the context of your request on the prompt window there. It just generates the code, that's all. It does not know the context, it does not know the business criticality. You are aware what kind of application you are developing, what kind of business that you are serving, who is the client, what data or sensitive data they use. All those things you know, but the AI tool, a Gemini chat window or a chat GPT does not know that. And when we say about authentication or identities, it's not about human identity or authentication. The human identity alone. It's machine identities also, right? Because in AI world, machine to machine identity is at the very massive scale, not the human identity part. It is everywhere actually, because the machine identities are quite unmanaged yet. Maybe after a year we will fix this whole mess of unmanaged identities in the machine to machine communication, API to API, platform to platform, all those things. Currently we are basically creating invisible backdoors. Even I don't know. That's why it is called invisible for me. Even I don't know whether something is there is a backdoor, someone can breach in. We don't know that. And then this configuration weakness. Oh, this is a silent killer, trust me. The most important thing every software person will know in his entire lifetime is, if the system or the application is working, nobody touches it. That's the rule we all go with. Until a public bucket, an exposed endpoint, or a library or a dependency you have used, or any missing logs turn into a nice breach story or a cybercrime story of your company. Till then, nobody really gives a damn about it. See, here is the part out of all these things, here is the part we as people underestimate. If you cannot log in, your company stays offline. Remember that. Your whole company stays offline. Because identity is foundational, folks. Protecting the identity is not just security. It's the most important business continuity, the BCP plan. See, we all can, okay, coming to the Thali example, right, which I started, we can all prepare a very good menu planned for Thali. But if the kitchen door is unlocked or open all the time and anyone can walk in, the ingredients can vanish, right? The groundnuts, the lentils, the oil, the mustard seeds, it can just vanish. We don't know who is taking what. And if you're talking, hey, it's all our family members, trust me, guys, any cyber report that you read from any year, it always measures and tells you that insider attacks are 70 to 80% in any year. That's the range. When it comes to cybersecurity, it is a serious business. It is a policing job that we have to do. And we cannot trust our own parents, our own siblings. They might eat up. We don't know. That is one thing. And if you really don't notice because there is no light in the kitchen, it's even harder, right? Who walks in, who took what, we don't know. You have to put the light there. And that's the missing logging part. For anything you deal with AI, the mitigation checklist which I have given is very simple. Lock the door, put MFA everywhere by default, unless there is a very specific business ask. Okay, this is a straight identity entry or authentication authorization requirement. Then only with all the controls and approvals, risk register maintained, you remove the MFA. Put MFA as a default thing there. Ensure the conditional access is properly managed. Keep the minimal keys, only what is required, the least privilege identity part. And then keep the lights on. You have to put the logs for everything, any action, because conventionally we were told, okay, username should be logged, user ID should be logged, timestamp should be logged, failed login attempt should be logged. No, there is no checklist anymore. Put everything into the log. And we have petabytes, zettabytes, whatever the byte size, the volume that we want to manage. We have good number of tools in the market. We have good number of people who can take care of it. Of course, it comes at a cost, but it's worth it. Put everything into logging and alerting. Ensure that the lights are on in the kitchen so that even if somebody walks and tries to do something, you will know who did what and you can take action. Lastly, this is where we stop fear mongering. I mean, I did not develop the whole drama of a horror story here, but let's try to understand how to build secure AI development practices. I'm not here to tell you how to build the AI software directly or on the operational or execution side. It's about the practices. The very first thing, policy. What's allowed, what's not allowed, where it can be used, where it cannot be used, what must never be entered into the prompts, how will you control it? Keep the things very simple. You don't are the best. I mean, with my experience, there can be better options than this. For all the folks who are looking for a straight away and a practical solution to manage this is the NIST AI framework. It is fantastic. And the second one is DASF, Databricks AI Security Framework. Excellent one. Very operational, very control oriented. These two, if you combine and put some things in place, your practice of using AI software development, trust me, is at least secured in the rudimentary way. Because everyday threats are evolving, folks. I cannot say 100% security for anything, but yeah, it can give you a lot of good guardrails, learning, policies, and stick to that. Next one is the guardrails. Approved dependencies, what are the safe templates to be used, and a rule that AI code does not get into auto run with power, all those things, you can do that. Importantly, the review part. For security sensitive parts, at least, if not all, humans should be still held accountable. Next one is the test part. You have to still run all the scanning and injection tests, pen tests. It should be by default. No escape. The last thing is recovery is the most important thing because incidents will happen, folks. Whatever the best defensive mechanism, offensive strategy you have, incidents will happen. For somebody else's mistake, we are here to suffer. And when you restore, you don't want to restore the infectious backup, right? That's why immutable and isolated recovery or the clean recovery really matters, and why you validate clean before going live again. So ensure that you have immutable backups because recovery is a overhead extra price, but still it's required, right? So remember, you can't optimize what you can't see. That's the first thing. If you don't have the visibility into where AI code is used in your whole ecosystem, what dependencies are pulled in, what libraries are incorporated, what secrets are touched, you can't control the risk. Visibility comes first. Get the whole register or the inventory done and then optimize it. Because even while cooking, right, we don't cook by taste alone, right? That's junk food on the footpaths. we follow a process. We clean our hands because it's for our own people, right? We clean the utensils with the right flame. We do the taste checks here and there, and we keep the backup plan as well, because some of the times, especially when men are cooking, most of the items gets burnt. With all the attention paid on the same vessel, we don't know, something happens in the background and some of the items get burnt. So having backup plan is always important. That's the restore part, right? So secure AI development is the same way, guys. So process always beats the heroic or the melodrama serials or the drama. Okay, one line from this slide before I end up: treat AI code as untrusted. Always have that mindset. Control your identity very tightly and build the recovery part you can trust, and ensure that happens with a lot of speed and recovery. Right? Don't ship the confidence. It's already out there with the AI. Always ship the controls. With that, I take a pause for any questions. I know I have just completed on time. Maybe the time is short. Titiksha, please let me know if there are any questions. I will try to take them.
Yes, there are certain questions.
Sure. Let me.
In the Q&A box, it's there. So do you want me to read it out?
No, I'll just open
Okay.
that here.
All right.
From which question are the ones I am supposed to answer? I did not follow
Sir,
what Brijesh
after
did.
130, after
130, yeah, that's a good one. 130, is embedded agentic AI vulnerable for system security? Of course, yes, it is. Agentic AI is so vulnerable because the visibility is very low there. We have to be very careful there. Great analysis. Hackers log in not broken because you gave them access. Authentication failures, too much exceptions without exception. Yes, that's correct, Sanjay. I agree. It looks like the past best practice: understand the libraries and APIs you are using in your software continues to be applicable for agent code and requires additional security intelligence. 100% Sri Harsha Narsimhan. Absolutely, you're spot on. Can use of AI generated code in small modules of overall agentic AI place the entire OS? By all means, Srikant. That's the tiny spark which can flame up the whole thing. So no non-negotiable, Srikant. Everything has to be with the right framework and the policy, the tests that has to go through. It can be small, it can be big, doesn't matter. How to identify the prone to sensitive information? Rizwana, the question is a little unclear for me, or maybe incomplete. How to identify the prone to sensitive information? If you are using any scanning tools with your CI/CD pipelines, they would usually flag this, but I'm little unable to be more context aware of this question. So sorry for that. Is uploading data to Copilot risky? It depends on the configuration again, Harsh Yadav. If your organization has the right security configurations where your backend, it's just a toggle button, man. In the backend, if the Copilot data is bound to stay within the company boundaries, then it's not a problem. But it all depends on the people who manages this Copilot license from Microsoft for your company. So they should be equipped and made aware. Now, how we differentiate Stack Overflow code snippets to AI-generated code? We don't have to differentiate, right? So as far as your work is getting done and you're following the process, I don't know. I mean, maybe Abhishek Singh, I'm unable to get the intent of this question, but yeah, that's it. So how will we, who will be held responsible if AI commits a crime? Are there any laws for AI crime actives? Ideally, Shijit, yeah, that's a very good question. Yes, my request to all the folks over there, because Professor Triveni Singh sir is also here. We at India level, we should, at least at a national level, we should collaborate. We should join the hands from the tech, non-tech, legal, policy making, governance. All these people should come together, and we should be able to draft out the required uh, action items for such crimes. So because human is definitely there, the brain behind, because at this moment, if I go and kill a person on the road with a knife is the AI in my hand. Who is killing? It's ultimately me. AI is still an instrument in the wrongdoer's hand. So we should come up with some real good policy. It is difficult, but it is needed. And Ashira sir, kindly explain what all considered safe when using AI generated code. I can send you a checklist, just because We don't have a 100% foolproof strategy for this Ashira yet, but we should, if required, I can connect with uh, the organizers and they will send you some checklists. It's all available over internet. My suggestion: go with NIST, ARMF, and also DASF frameworks. They are very, very good. AI software created. I didn't understand. Okay. Don't the Stack Overflow code copying carries same risk as AI generated code? Oh yeah, Abhishek. Yes. Now I get the intent. Yes, that is very true. It does carry, man. It definitely does carry that. If criminals modify AI generated code often after creation, how can investigators still identify the AI origin of the code? That's a little subjective, Pula Lakshmaya, because when you say criminals modify AI generated code after creation, what do you mean by creation is the question here. Is it after the application is into the production, or the AI generated code you modify before doing the production? It all depends. That's the reason I said having a bright light in the kitchen is very important. Your audits, your logs, your policing policies are very, very helpful. Everything that anybody does has to be logged. Then only the frauds can be caught. Can you mention the framework names again? Yes, Supreet. It is called NIST AI RMF, Risk Management Framework. That is the first framework. The second one is DASF, Databricks AI Security Framework. I repeat for everybody's usage: NIST AI RMF, DASF, Databricks AI Security Framework. And that I think that answers your question. Yes. Thanks, Triyash. Titiksha, that's the last question I see. I know I've already overshot by 6 minutes answering these things, but just let me know. Any other questions, anything that you would like to know? I'm here.
No problem, sir. Even if you exceeded 6 minutes, I think it was beneficial for the audience.
Thank you.
So thank you so much, sir, for distilling the 30 minutes of AI insights. I think all these things will stay with us for a lifetime. So now I welcome our third speaker of the day, Mr. Barun, sir. Sir, are you there?
Yeah, hi. Hi, good afternoon, everybody. Am I audible?
Yes, sir, you're clearly audible, but before proceeding, I would just like to give a small introduction.
Yeah, sure.
So, Barun Kumar, sir, is a technology and business leader with over 20 years of experience spanning engineering, product development, sales, and marketing. Sir's expertise spans AI ML platforms, SaaS analytics, IoT solutions, and advanced semiconductor IP. We are happy to have you, sir. Handling over the platform to you now.
Yeah, thanks, Titiksa. Sure, let me share my screen. Please let me know if my screen is visible. Is it visible?
Yes, sir, it is visible.
Okay. So, in the last session, we have seen how the AI generated solution or code should be looked up, and we should be careful when we're using. In this session, what I will try to focus on is that how AI can actually help us to identify those security threat and also to create a response automatically. So here actually we will try to get the good parts of the AI and try to use to improve our threat detection and responses. As we all know that the more and more applications are going to the cloud environment, and also people are using remote devices, and that actually increases a lot of security threat. And that is the reason the security attack, malware attack, or breaking to the system is much more becoming much more common. Now, going with a traditional security framework where the signature based threat detection or rule based threat detection is no more sufficient. We really need to come out with advanced security threat detection so that the new threat can be identified and detected, and they are also get neutralized. So that's the one of the key thing where AI can actually help us. Yeah, so here actually now the attackers are constantly evolving their techniques. They are exploiting unknown vulnerability because what is happening, the typically the new malware is coming, new attacking strategies coming, and it is impossible for an human being to understand those strategy or be aware of those strategies unless those become very common and those are really deployed. And that is the reason AI can learn and also learn automatically, understand those strategies and take necessary action. So this is the limitation, as I mentioned, with the traditional security system. It is all as signature based. It all depends on the known threat pattern and static rules, and it is all rule based. And it has a limited adaptability. If there is any unknown or evolving threat is there, it cannot work effectively. Now, how the AI can help? So AI can just goes beyond this traditional method. It can monitor the complete uses of the system, and based on the uses of the system, it can actually take a decision that whether there is something wrong is going on, and if something wrong is going on, it can also then take the necessary action. So one of the few of the examples actually it can monitor the network traffic, it can monitor the user behavior, system logs, application uses, endpoints telemetry, and we can come one by one. So typically, let us assume that there is an enterprise and there is a certain network traffic happens in certain in a time of the days. So AI can learn, okay, this is my normal network traffic. I mean, maybe in the daytime the traffic is high, or in the nighttime the traffic is low, those kind of thing. And in this process, it will learn the typical pattern, the typical pattern the organization will follow. Now, if it detect any kind of issues, any kind of anomaly in the network traffic, then it can identify, it can result that, okay, there is something may be wrong and there is some attack may going on. May be tried or may be targeted, and then it can take the necessary precaution. Maybe it can shut down the system, shut down the access to some critical system, or it can request for extra authentication mechanism. Those things can be it can do. For example, it can also monitor the user behavior. So if there is any change in user behavior, then all and if it can detect automatically, okay, there is a change in user behavior, and with this change, it can actually then ask for request for a extra security measure. Just to give an example, Apple has implemented this thing very effectively. So what Apple does is Apple automatically detects the location intelligence. Basically, it detects that from where typically the user login. So it creates a location boundary. Okay, the user of a particular Apple iPhone tries to log in this particular location, and they mark this is a trusted location. Maybe it may be person home, person office, or those kind of thing. Now, if they detect that, okay, the same account, there is an attempt to log in from some location which is actually very remote and which is not in typical user behavior, then actually they ask for the extra authentication system, maybe in terms of face recognition, or maybe in terms of OTP or something else, or they may even block the access to certain storage into the iPhone. So that they have implemented. This is one of the user behavior pattern monitoring, and that is the way AI can itself learn and deploy and then identify the security threat. Another example may be that when the user typically uses his system, is it a daytime, is it a nighttime, and which kind of application typically he is using. And if the AI sees that, okay, there is some significant deviation from that behavior, it can also create a special firewall or special additional protection mechanism. For example, maybe the user is just doing a browsing in some, say, Chrome browser or Mozilla Firefox, and suddenly AI detect there is a huge amount of data, network API call is happening, which is very not very common, because if I browse something and maybe I can download and upload data. Even if I download and upload data, number of API call will not be very high. It will be very limited. Now, if AI sees that okay, there is a significant number of API call is happening to from to the system, then there is something an issue, and then AI can take the necessary mechanism. Even it can monitor the payload, what kind of payload the user sent in with those API call, and if it detects any kind of anomaly in those payloads, it can actually detect the thing. Of course, the system logs are quite common. With the system logs, AI can create its own understanding of the resource uses or those kind of thing. And if there is a deviation, then AI can take action. For example, the previous example is browsing. Of course, browsing will not take a significant amount of CPU uses, because even if downloading, uploading, it's a very minimal CPU users typically happens. And at the same point of time, if AI sees okay, this is some application is going, which is which is typically supposed to take a low amount of CPU uses, but suddenly some jump in the CPU users happen, then AI can actually take a preventive measure. So how, okay, the next thing is, so in the previous slide, we have focused on the learning of the AI and more like an anomaly detection. Now here we will try to focus on how we can actually make these AI model or machine learning models to understand those historical data and to understand the malicious activity and take a necessary action. So there can be multiple types of training possible. Of course, one is the supervised learning thing, where actually the model itself get learned about the um, malware which are typically available. So they know that okay, if this kind of files or this kind of file extension come, for example, the binary file extension, this can be a probable malware. So I should block this file download, or I should block this file installation. So that is the supervised learning. Then come to the unsupervised learning, where AI learns itself. There is no labeling or annotation done on those activities. It's more like AI understand the boundary of the typical things, and it detects the anomaly. And then, of course, the deep learning method is there, where the advanced behavioral analysis is done. So basically, then we see the AI can actually go to the behavioral analytics, where it can actually look at the baseline behavior of the user, devices, and application. Maybe the application, what can be, it can actually look at what kind of resource the application uses, what kind of API rate the application is trying to call, or what is the workflow or the API call, which API is getting called after what, or typically what are the fields in a particular database is getting accessed. All those things, behavior AI can learn. And if AI detects any issues, say in terms of say login location or abnormal data transfer, then it can actually create a protection mechanism, or maybe say it can block some critical portion of the thing. For example, if an application say has a personal data, maybe name, email ID, phone number, and stored, which is called the personal data, which is sensitive data. And typically the application maybe uses those data only at the time of extract those data only at the time of login or say. Now, if AI learn this method, okay, only at the time of login, this information get accessed. After that, this information the application will never access. Now, if AI identifies something, identify that okay, the user is logged in for say more than 5 minutes, but this personal data is somebody is trying to access this personal data. Somebody means some API is trying to access this personal data, then there is something wrong. I mean, it is not a typical way that application is supposed to behave or the user is supposed to behave. So then definitely it can block the access of this personal data, and it can maybe log out the end the session, or maybe log out the person automatically. So those kind of things can be done. Now, of course, when it comes to the log analysis, there is a huge amount of log, and where actually to understand that these logs is there is no certain rule on these logs. So there, the natural language processing or NLP can be a really effective way to understand the logs and to automate the incident investigation. So the NLP, natural language processing, can continuously monitor the log, identify the security alerts and with the known attack pattern, and then if anything can happen, it automatically create the incident report. And that's where natural language processing can help. So this is a very what I say very summary of how the AI-driven threat intelligence can work. So of course, it can look at the security logs and identify the issues in the logs. It can identify the anomaly. It can identify the targeted access to the vulnerable portion of the database, and that the way it can identify the detect. But it's AI can not only can not only help us to detect a security threat, but it can also help us to respond to the threat, where it's more like a agentic AI kind of thing, where AI is identifying the threat, and then depending on the threat, it is helping to it is taking an action to isolate to prevent the threats. What can be the prevention mechanism? It can isolate the devices automatically. So if it detects a threat, it can automatically isolate the devices from the compromised endpoints. And then unless the threat is rectified, or it is communicated to the human user, and human user takes the necessary action, then till that time the device can remain isolated. It can block the malicious IP address in real time, so that those any request from those IP address will not be entertained till the human user actually whitelist those IP address. So it can put those IP address automatically as a blacklist IP address. It can even automatically reset the credential to ensure that if the credential is reset and the user again start the session or log in from fresh. And of course, last but not least is that it can trigger the alert. It can automatically activate the security workflow and create a notification to the real human, so that real human can actually get more, try to get more information and try to take necessary action. So what is the benefit? So this is my last slide. So now what is the benefit of AI in cybersecurity? We have seen that it can help us to identify the threat detection in a much faster way, And also the new threats, or it can identify new threats it can identify. So it's the first is the automatic detection of threat. It's not like that somebody has to sit on the in front of the monitor, continuously look at those resource uses or login location or network traffic, and somebody needs to really manually trigger the threat detection. AI can do it itself. It can actually then take the also it can identify the new threats, which is not possible for typical human being. If any, say for example, these things happen nowadays, is that the malware, the attacker always do a little minor changes in the malware so that the signature does not match. So AI can actually, in our previous scenarios, when we used to do the signature-based mapping analysis, due to the change of signature, that even the same malware get installed, and it can create a security threat. So AI can actually look at the complete binary file, and they can identify, okay, this is the previously identified malware binary, a new file which have been trying to get installed, has the very similar kind of pattern. So this is a possible threat, and it can actually block that binary file. And of course, AI can run 24 cross 7 without any human intervention, take a real-time action, and improve the scalability. And last but not least, it can automatically create a response mechanism, not only to detect the threat, but also to ensure that the threat does not do any damage, or at least the damage is very minimal in nature. Yeah, so these are my presentation, and I will be glad to take the questions, if any.
Yes, sir. Yeah, there are questions. One of our participants has put up.
Yeah.
They want to ask, can you suggest and recommend any good tools for AI powered threat detection and prevention? And also they want to ask if there are any, if you can recommend good AI powered threat response tools.
There is no tool as such. Of course, Copilot is there. I mean, if there is a AI powered tool threat detection, it is, I will say, uh, as of now, tool-wise, any code we are deploying, we can run through Copilot to figure out the tool, and that is the, I will say, the best option as of now. But yes, I mean, there can be a code which can be generated automatically, security code using the AI, and those things can be used for the AI in that deployment.
Yes, sir. There is another question. When an AI system automatically blocks a malicious IP address, how can investigators identify the real attacker if the IP belongs to a VPN, proxy, or botnet node? How can investigators correlate blocked IP addresses with global threat intelligence databases?
So you are telling it's more like an investigation point of view. Of course, if it is a VPN or those kind of thing, it's not possible. But what can be done is that IP address will be blocked automatically, and no access will be taken. No access will be allowed from that IP address. Now, what may happen is that if this, I mean, of course, as a human individual, we cannot go to the investigation, but that IP address can be reported to the appropriate authority. Okay, this IP address is something which needs to be looked at, where there is which seems to be a malicious IP address, And then, of course, the investigation authority can go to the, say, maybe the VPN provider, the provider who is providing the VPN. They can go back and say, okay, this is the VPN IP address which has been targeted, I mean, which has been detected as a malicious IP address. And then they can get the real IP address, of the real device which has tried from that VPN service provider. So yes, as an individual, it may not be possible, but as a institution, they can actually go to that necessary organization and get those information.
Thank you, sir, for sharing your profound insights on AI, leaving us with a wealth of knowledge and inspiration to explore further. Thank you, sir.
Thanks a lot. Thanks.
I now invite Dhananjay, sir, for giving us a new viewpoint today. Sir, handing over the platform to you.
Yeah, thank you very much. And it's a pleasure, first of all, to be a part of the FCRF forum. Special thanks to the organizers, and extremely happy to be here. Among the participants, I see a lot of friends, a lot of law enforcement. So yeah, I'm very pleased to be here. Am I visible, audible, first of all?
Yes, sir, you are visible and audible.
Great. Okay, so screen visible?
Yes, sir, it's visible.
Excellent. So thank you very much. I would just give a quick introduction about myself. So my name is Dhananjay. I have been a former CISO for a long time and now working with iManage. So I have, first of all, wonderful views by all the participants here. I will just take a slightly different approach on this. And because I come from the CISO community and now on the other side of the table, I would like to present, a different perspective in terms of AI and give you guys a little bit of bad news, unfortunately. Okay, so just like everybody has seen the movie Dhurandhar, right? So the guy broke it up in chapters. Okay, so this is what we plan to do. We'll just quickly look at the evolution of cyber threats. We'll look at what kind of defenses we have. So there are a lot of CISO friends in the community now. Everybody has the best of tools, orchestration. They have the best of managed security services, human in the middle, automated services, and so on. So we'll look at that. We'll also look at what are actual AI threats existing today. We will look at why your defenses are going to fail. Okay, in today's world, how is AI applicable, not just in a cyber sense, but affecting real life? So we saw a lot of examples from the speakers, deepfake phone calls, deepfake videos, and so on and so forth. We'll look at that. And mainly, I would like to, because we are a Make in India startup, so what India needs to do and why are we a little behind. Also, because we have a lot of law enforcement agencies and policymakers in the audience, what is it that we need to do to empower our agencies, and what is it that we need to do in terms of compliance as a national effort? Okay, so moving on. So essentially, 1990s, basically, we had viruses and worms, something this, previous speakers have covered. So I'll just little bit, I'll kind of run through this a little bit. We moved on from basic viruses, which were caught by, signatures. So essentially, you updated your antivirus in the morning. You knew you were safe until tomorrow. The next signature came, and then again you kept on working, and so on and so forth. But then that ended. Eventually, Trojans and botnets came into the picture. So there was a era where denial of service and so on came to, action. So basically flooding your infrastructure with so much of traffic that eventually the infrastructure will break and topple over. Then came the espionage, where we have advanced persistent threats and ransomware, uh, where the threat actually sat in your environment for a long time. And finally, when it got a chance to communicate with its command and control center, it activated and exploded. So thereby compromising either the host or the network segment or the entire organization and so on. Ransomware, obviously, a different game altogether, encrypting hard drives and exfiltration of secret information. Now we are looking at AI agent and deepfakes. Okay. So basically, again, we started with viruses, worms, then I Love You 2000. I don't know how many of you were there during that era, but yeah, this was one of the most nuisance making virus in those days. Then we had a lot of similar Trojans, people downloading freeware, games, etc. From the internet. Adware started coming in, and so on and so forth. But those defenses at that time were enough uh, to take care of you and your network. So again, I'll not go into this, but basically a Trojan is something that the user essentially downloads on his own. uh, he's enticed by the fact that it is a freeware or a free game or a free software, pirated tools, cracked tools, etc., etc., and then eventually infects the host. So we have different varieties of that. Now we have the Dark Comet Rat, now which is a remote access tool, which gave for the first time in history, it gave complete access of keyboard, camera, mic to the attacker. Okay, so the attacker just watched what the guy typed. So he was able to record username, passwords, everything. He was not interested in infecting the host or destroying the host. Came, mass attacks or state actor attacks, black energy, the Ukraine power grid. For the first time, an entire country was in a blackout. In again 2025, we have seen the Tesla, which is a kind of multi-vector attack, wherein people were getting phished. The DNS infection or DNS sinkholes were happening, and thereby people were getting trapped. Firewalls weren't able to do anything. Antiviruses weren't able to do anything. And essentially, it had to people had to resort to formatting of machines and formatting of critical infrastructure like servers, etc. Again, like I said, DDoS, weaponizing to scale. So DDoS happens in two types. It is a singular distribution, singular denial of service, or a bot-based distributed denial of service, where basically it overwhelms your infrastructure or overwhelms your application architecture to topple it. So it may be your firewall, then it may be your IPS, then it may be your web server, your database, or the underlying operating system. So it stress tested it to the limits where basically it had to crash. But then we found a way around this. So we found that rate limiting helps minimize this, not stop it though, but minimize this. And we eventually got around DDoS, DOS and DDoS attacks. Ransomware. Now, the most scary part, ransomware yet is one of the most expensive, one of the most expensive threat that the cyber world has seen, because the infiltration happens through multiple vectors. It is able to recon, map entire networks, give it back to the controller, and then perform lateral movement across the entire organization. In many cases, we have seen that unpatched switches, unpatched routers, unpatched firewalls, the ransomware was able to move across VLANs. Okay, so even that defense of segmentation wasn't working. And eventually, encryption of the hard drives happened across the organization, and a ransom demand was placed. The demand usually happens in Bitcoin currency, so that the attacker remains anonymous. So WannaCry, one of the most popular, and Logbit, one of the latest, which has the maximum amount of victims globally. Advanced persistent threat, like I said, it it's a very silent but deadly killer. It sits in the network for 6 months. There have been instances where it has sat in the network for 2 years before exploding. Uh, it waits, watches, and mainly APTs are designed by state-sponsored groups because they are very complex pieces of software that are injected with great amount of sophistication. However, we do have certain amount of controls around this, and a lot of you will say that, hey, we know about antivirus not working, and we have better systems in place. But bear with me for some time. There is more bad news. So, what is happening today? Okay, so the entire threat landscape is changing not by the month, not by the week, but basically by the day and by the hour. We are having agentic AI attacks. The previous speakers have spoken about this. Very problematic. We have AI-powered deepfakes. Again, many of us get blank calls. Many of us speak on those blank calls, and our voice gets recorded eventually. And too have experienced this. I have actually got a call from my sister-in-law asking exactly her voice uh, for urgently needing some money because she was stuck in a hospital or something. And it uh, like the previous speaker said, it kind of put me in a shock for about 5 minutes. But then my patience paid off because I tried calling back again and again, and until she picked up, I re-verified. Supply chain attacks. So we depend on a lot of update channels. Okay, so our Microsoft Windows update, our let's say Microsoft Office updates, or our Linux updates, our GitHub updates. Now it's very easy for that to be compromised, and the update itself is infected, and thereby infecting the host and the entire organization as such, because the update is pushed across by the administrator himself. Then we have AI generated malware. We'll look at this in a little more detail as we go on, this and the shadow AI part. So these are basically polymorphic malware. They learn, they do not explode, they keep learning on the host. They determine the entire telemetry of traffic. They determine user behavior on their own, and it's very difficult to stop this. Okay, shadow AI basically happens because of insider usage, wherein employees start pasting sensitive corporate data information into LLMs. Uh, one of the query, a previous participant asked, is it safe to, uh, you know, uh, use Copilot in an organization? So a quick history, and you can, verify this fact. Do you know that when Copilot was in its early stages and the betas were out, uh, you could ask Copilot that help me activate my version of Windows. Please provide me keys to Microsoft SQL Enterprise 2024, and it would actually give you the answer. Please give me email addresses of Microsoft employees. It would actually give you the answers. So yeah, the, AI models are problematic. I'm not saying the problem exists now. Microsoft has fixed it, but yes, the scope of these things have to be limited, and you have to be really very careful in terms of what you actually reveal to any kind of AI when you're either generating code, or you're generating any kind of material, or you're subject to plagiarism and copyrights, etc. There's a lot of things. Model poisoning, again, previous speakers have spoken about this, wherein corrupt AI training pipelines, you have copy pasted code, and AI basically just goes on the internet, and there are malicious code libraries there. Unfortunately, AI doesn't understand that. AI just knows that it has to solve your problem, which means that your software has to give a specific output. So it gives you that output in the fastest way possible. And thereby, poisoning attacks are happening. Uh, Recently, Claude and Anthropic both were in the news because of model poisoning. And it is, again, a statewide, international wide issue. So signature-based defenses have failed. Very simple, polymorphic. The hash value doesn't add up. The code mutates and changes itself every so often. It is impossible to catch. IP match, again, it can come from any IP. It can mask its own IP. Uh, you cannot depend on firewalls and IPS anymore. Okay, so uh, it is again very difficult with heuristics or behavior analysis alone to just simply rely on AI related malware anymore. So this is again basic signature based defenses. The end of the world. I mean, it's gone now. So, so people have the argument saying that, hey, hang on, I have sandboxing, I have the state of the art, the Palo Altos and the checkpoints and so on and so forth. So I now explode my payload, suspicious payload on a sandbox. Now, here is the bad news. AI detects sandbox. In the sandbox, it does not explode. Okay, how much ever the sandbox tries to, as soon as it detects a underlying virtual machine, it does not do anything. It just sits there, and the payload eventually gets through your firewall, IPS, EDR, and lands. Okay, it is a context aware payload. It waits until it has hit production, and it knows that it is not yet through, so it does not it is in no rush to attack. Like the previous examples that we saw, viruses and worms, they are in a rush to destroy the environment and basically cause a denial of service by either a blue screen, system shutdown, or crash, or something like that. AI malware is in no rush. Okay. So again, death of the traditional antivirus. Okay. Then all of you will have the argument saying that, okay, encrypted channels and SSL. So 85% of malware uses SSL now. Okay. So antivirus cannot inspect this. Okay. Unfortunately, when the payload lands, it is already coming via an encrypted channel. So again, landing it, decrypting it, and trying to explode it, it doesn't work. Uh, we have polymorphic blindness. Modern AI generates basically millions and millions of variants per hour, and it throws the entire payload onto an organization. It is a very targeted attack. So the idea is try till you succeed. So essentially, like a baller who can probably afford to make mistakes and probably bowl 10 white balls in an over. Okay, but he has to get one ball right. Okay, while the batsman has to get all the balls right or he's out. So it's that kind of a environment that we are in today. Okay. Apart from this, obviously, the DLLs, etc. I mean, it's again, a fatal trust assumption that when you open your task manager, your explorer.exe is safe. Sorry, I mean, again, that has become a myth now. The polymorphic malware can be in any form or shape or in any file, and they are most likely fileless. Okay. So, again, now all of you will say, hey, but we have moved on to EDR. Okay, now here is more bad news. Okay, so EDR covers endpoints, it is blind to cloud, email, network layers. Okay, now again, it requires, a lot of expert human beings to write custom rules. You simply cannot rely on EDR responses alone. You Because polymorphic malware is in no rush to explode, the EDR response or the EDR isolation that the EDR is actually responsible for does not work. So EDR has now also taken an upgrade, which is good news. So we have cross-layer XDR, cross-layer, or some people call it extended detection and response. Then we have managed detection and response. But again, let me extend some more bad news. Okay. A lot of you will say that, we go beyond XDR and we go beyond MDR, and then we have, human in the middle, and we have SIEM, and we have orchestration. Okay, but each of these has a limitation, and unfortunately no one is even close. None of the products, we meet with so many customers, none of the products are even close to millisecond response, or millisecond when I say response, lockout or isolation of the system. So as of now, there is again no active defense against polymorphic malware. So what is polymorphic malware, and what are these agentic AI attacks? They are self-directed. They write their own exploits. They scan the network on their own. They modify their own binary. They latch themselves into your RAM or persistent memory or virtual memory. And because they come from maliciously generated AI code, they are almost able to evolve with respect to patches. They are almost able to evolve with respect to response of the OEM, and thereby it almost makes them literally impossible in the current age, literally impossible to track, detect, respond, and recover from them. So agentic AI can be given a goal. It can be told breach the network. It can be told detect critical resources. It can be told to uh, write itself for a particular host, for example, it can write itself for Microsoft underlying operating system, Linux operating system, a Mac-based operating system, Android-based, underlying OS, iOS-based underlying OS, and the problem here is that it is actually able to perform a vulnerability assessment of the host itself, record vulnerabilities, and explode when it wants to. Okay. So this is a quick mutation engine that how it works. So we have the recon feed. Okay. Then we have the AI malware generating the zero-day code. It crafts the payload. Okay. It looks for sandbox. Okay. It will not explode until it knows that it is there on the actual host or production host that it desires, on the crown jewel, if I may. It mutates and evolves. It has to mutate and evolve because it wants to laterally move on to other crown jewels, and eventually it latches on to the entire organization. And when it latches onto the entire organization, it takes a feedback loop from the security infrastructure itself. So, for example, as your EDRs and XDRs evolve with signatures, it is also evolving at the same time. And it is taking a continuous loop, it is continuously improving itself, and it will explode when it wants. So, again, we'll just quickly run through this. It does a recon, it weaponizes itself, delivers exploits, and persists. Okay. So when I say exploit and persist, two different things. Exploitation means it has done the job. Okay. Then your EDRs and XDRs and SIMs and source come into play. This is where you, as a security administrator or as a SOC manager, you get the feeling that, you know what, we've cleaned or we have wiped this infection. We are now good to go. But it does leave a residue, and therefore the final step of the AI attack life cycle, which is persist. Now, all of this, okay, is done literally in a matter of minutes. Okay. It has done deep discovery of your organization already. It has correlated itself with MITRE databases, attack and defend frameworks. It has already gone through CVEs. It has done everything. And we have already recorded this for Fortune 500 companies that under 10 minutes, the entire game is over. Okay. In terms of weaponization, the average time to generate a working exploit is under 15 minutes. Okay, so this is how fast this thing works. One of the latest malware which is available on the darknet actually for sale is Promflux. And Promflux is basically a very deadly polymorphic malware which uses very advanced deep learning technology, and it modifies itself by the second. It is really, really difficult to catch. So, what kind of defenses typically an organization have? An organization has at the perimeter level firewall and IDS. I already spoke about the fact that it is very easy for them to bypass this. Behavior analysis. Okay, because these things are vibe hacking. Okay, when I say vibe hacking, I mean that it runs with the vibe. Okay, so it is changing itself and automatically blending into the production environment. Okay. I think almost all of the speakers have spoken about the fact that, zero trust, many people feel, and it is one of the most misinterpreted terms in the industry today. Okay. And people have become billionaires by selling zero trust. Unfortunately, people don't understand that zero trust is not just at your network layer and micro segmentation. It goes much more beyond that. Zero trust is a evolving and lifelong process, and these polymorphic codes are programmed to respond to multi-factor authentication, hijack OTPs, and respond to that. They are also able to bypass captchas. So yeah, good luck trying to catch it using that. We already spoke about the fact that AV and EDR are defeated. We already spoke about sandboxing being defeated. SIM and SOAR, because they show up very, very late in the logs, unfortunately, and they dwell for almost 5 to 6 months. Unfortunately, SIMs are unfortunately not able to help. Okay, so which company has signatures for polymorphic AI malware? The best of our knowledge, none, and there are zero signatures globally as of now. Okay, so indicators of compromise and indicators of attack. Okay, we highly rely on this because we have CTI and threat exchange platforms, and we have the OTXs of the world. In fact, at iManage, we have our own CTI platform, which we give our clients, and we have mapped it to the national CIS, which is Critical Information Infrastructure of Bharat. However, because it doesn't have a fixed file name, it doesn't have a fixed domain from where it comes from, it doesn't have a fixed hash value, it doesn't have a fixed SHA or MD5. IOC is very, very difficult. Okay, it is literally impossible. Then most likely, if you are a Windows user, you will most likely know as a as a security professional that you have to look at registry keys mainly in a Windows environment. Again, there lies in the problem. At every host, at every target host, it creates different changes to different registry keys, therefore again making it extremely difficult. Indicators of attack. Now, indicators of attack is where we look at behavior patterns, where we look at lateral movement, privilege escalation, and so on. But again, indicators of attack, IOA, they tend to fail here because the polymorphic code is in no rush. Okay, it wants to sit in the environment, it wants to dwell, it wants to learn as much as possible, and because it is living off the land, which is the LOTL legitimacy, uh, it uses your own tools against you. Okay, not only is it able to impersonate people, impersonate identities, it is actually using your own tools against you. So again, thereby making it a near zero possibility using simple IOC and simple IOA to catch it. So how does this happen? Okay, uh, so we have reinforcement learning. Uh, you know, uh, it tries. It has got infinite number of attempts. Okay, so basically, it is going to try till the time it has what we like to call a PhD in your organization and your security architecture and your telemetry and your response time and what it is that your SOC team does. Okay, polymorphic, we already discussed this. Every second, probably every millisecond, it has the power to change itself. It has got cross-organization learning. Advanced actors are actually able to learn from organization A, empower the other polymorphic malware to strike organization C, D, and E, and so on. It is superb at doing fingerprinting. Okay, it is superb at identifying operating systems. It is superb at understanding where it is standing. It on physical hardware, virtual hardware. It is standing in a sandbox, so it will pretend to be extremely innocent file. It understands, and builds a precise telemetry, like I said. Timing adaptation. So it if it triggers 10 actions a minute, it slows down accordingly, then it quickens accordingly. It waits for your EDR, XDR, SOAR to actually do something about it. But in the meanwhile, it has already laterally moved, or it has escalated its own privileges, and it has done the damage which it has to do. Okay. AI attackers specifically target and poison, the defense systems itself. Okay, so it feeds your EDRs, it infinitely feeds your logs with something, and completely distracts it onto non-production or useless targets. Okay, and all of a sudden, the entire attention is distracted while it goes on its hunt for your crown jewels eventually. So this is a very quick kill chain analysis. It already has done an OSINT of your organization. So basically, it has open source intelligence. It ha it has the knowledge of reading. So one of and we'll come to that example. One of the AI malware that we know, it actually reads Google News about your organization. It knows who is who. It knows who is a top guy, and it knows who is not. It knows what kind of infra you have. It knows what kind of protections you have. It knows what kind of deals you have struck. It knows who are your partners. It knows what kind of second layer, tertiary layer of layered attacks, layered defenses you have, and so on and so forth. And then delivery, exploitation, installation. Eventually, it contacts its command and control, and at this point, it is too late. Because it has already told its controller or its handler that this is the information I have, and now even if the attack kind of fails, the second wave of attacks is now ready. So there are some things that we do have in place. Okay, so for example, you can do dark web monitoring. You can understand, your attack surface, study it in more detail. You can reduce your attack surface intelligently by taking continuous action. You can do red team simulations, but it has to be continuous. It cannot be, say, once a week scan or once a week threat hunt or something like that. It has to be real time. Email defenses. We'll come to email defenses. There is unfortunately a problem here with email AI defense, although there are products today being sold under the fact that they are AI enabled email security solutions, and phishing is impossible. But unfortunately, in the AI threat landscape, they are two steps ahead, and we'll come to that. Fileless attacks, we've discussed this. DNS sinkholes, yeah, so it creates its own. Your SSLs are essentially useless. Your encryptions are defeated very easily. And you can basically do, a behavior anomaly or a behavior analysis. You can have a DLP in place. You can have micro segmentation, but again, with limitations. So we are not talking about foolproof. We are just talking about minimizing as much as we can. So fighting the new threat requires AI. So basically, we need AI to fight AI. Okay, but the bad guys have an upper hand already. So we need AI-based anomaly detection. Traditional systems do not work. We need dynamic deception. So basically, again, honeypots, decoys, which are AI enabled. Okay, so they will not do a single sandbox and one attempt to explode and then let it through. uh, we have to do it over and over and over and over again. Change the honeypot environment, pass it through multiple honeypots, and that is literally the only way to catch it. One more thing is, to stay ahead of the attackers, you need not just cyber threat intelligence or CTI feeds. You need predictive threat intelligence. You literally need to predict these things well in advance, and you need to have feeds in place, and you need to have your orchestration ready, orchestration mechanism ready, your human beings well informed, who are managing and responding. Apart from this, threat hunting, something we already discussed, micro segmentation. So we need AI based micro segmentation. You cannot rely on the fact that I did micro segmentation about 2 months back. It is going to work for me today. No, it is not going to happen. As a large organization or as a hybrid organization that relies on on-prem, off-prem, public cloud, you have to continuously evolve your microsegmentation at the speed of the AI threats. Okay, so you need to do that. Zero trust identity. So continuous authentication. Again, previous speakers have spoken about this. The attacker no longer hacks in or breaks in, or he breaks your door or destroys your defenses. No, he literally logs in like a normal user. He literally feeds in an MFA. He bypasses a CAPTCHA and comes into your network and sits and dwells like a normal user. He even logs out and logs in again. Okay, this is the smartness of the new threat that we are addressing as of today. So we spoke about email AI defenses. Unfortunately, what we have today in the adversary community or the attacker community is automated AI phishing factories. Okay, where target profiling is done, uh, persona cloning is done. Okay, content is literally customized to beat all these systems. Okay, and it is able to mass deliver across organizations because it does not come from one IP, where an orchestration system will look at one IP flooding your system with thousands of emails. It will come from various sources. It will bypass your SPF, DKIM, DMARCs, SPF plus, etc. And eventually, it will land and credential harvest. It will just dwell and take over. So we have these AI phishing factories which are running with 94% open rate, 73% submit rate. Okay, which means they are not only 94% of the users are clicking on the link, 73% are submitting their credentials after clicking on the link. Okay. Uh, so BEC basically is one of the biggest examples. They lost a bunch of money, 2.9 billion, and this factory cycle time is less than 5 minutes. It's globally estimated to be at around 4 minutes. So basically, the evolution or improvement of the phishing factory takes only 4 minutes. The current gaps. So we have the false positive trap, obviously because polymorphic. The poisoning problem. Your systems, so-called defenses, which are deep learning, which are AI based, which are ML based, it is actually coming and poisoning them itself. Okay, so therein lies the issue. The shadow agent risk. Okay, so defensive AI agents come in, after high value targets, and they are they, because they've already compromised your defenses. Okay, so they are able to cover themselves and sit in as shadow agents. We have a human being problem as well. Okay, there are 3.5 million security professionals globally, 5.5 million open positions. AI requires even more specialized talent to operate. Uh, you know, uh, Defining a defense for AI-based adversaries requires ML-based experts, AI-based red teamers. They require model trainers, model auditors, which is again a huge problem. Now, regulation friction. Okay, so this is where Bharat is slightly behind because the GDPR Act, came in first. Uh, so number one, they restrict a lot of their learnings to themselves. They don't let stuff out of the EU or the US. Okay, so this is where our regulation lacks a little bit, and we'll cover that a little more in detail as we go ahead. Speed asymmetry. Okay, so again, the best defenses, AI takes about 200 milliseconds to detect and respond. Unfortunately, AI threats are operating in single digit microseconds. Okay, so this latency gap is what is defeating your current defenses in place. Okay, so some real world examples. So we have so one specific example I want to actually harp on here is the Jasper fleet, North Korean attack that happened on the US. Okay, so you have job sites which post, open job opportunities. Okay, and this is how these people used AI to deepfake videos, give interviews, okay, get jobs, okay, and actually lodge themselves into these Western countries. Okay, and one of the reasons why the Trump administration is under attack nowadays, because of the excessive use of ICE agents everywhere, and they're deporting people left, right, and center, is problems like these. Uh, the other is obviously someone already spoke about this, the Hong Kong episode where entire deep fake video call was conducted with the top guys, the members involved, and unfortunately a junior employee uh, executed the transfer of $25 million to the attacker's account. And yeah, so this was the first recorded deepfake wire fraud where an entire video conference with the leadership was successful. Okay, and nobody suspected anything. Uh, the one of the latest one is obviously I don't know how do you say this, lame hug lamb malware. So this actually calls system commands on the fly. It makes static analysis of the host. It automatically targets and hunts for OT ICS systems. It latches onto them because OT, IoT, ICS, and SCADA systems are generally the ones which remain unpatched in most manufacturing organizations. The reason being, manufacturers are interested in efficiency, they're interested in speed, they're interested in optimizing factory time and factory output. Security of the IoT or the conveyor belts or the pressing machines or whatever be it, robotic warehouses, it's really not their priority. So this happens to be again a kill chain that exists over here. So coming back to India, we had the AIMS ransomware back in 2022, wherein patient records, the highest number of patient records were breached, and this was attributed to a state actor from China. The Coin breach, again, this was unfortunate. We all had Coin, installed on our phones, and we did not delete it after the pandemic went. And as a result, because it was based on Aadhaar authentication, a lot of our, PII was breached at that point in time. So we basically had railways breach, then we had the UPI deepfake fraud. So UPI deepfake fraud is, by the way, still happening. Okay, so you do have random voice calls from, sir, I am your account manager calling from so and so bank, because he already has your details. So he knows which bank's name to take. So he will specifically come and target you, and he will ask you, uh, basically, insist and create a sense of emergency to for you to take some action. Click on some link, go into your UPI app, your GPay, PhonePe, or so on and so forth, and do commit to something. Okay, and that is still happening, unfortunately. The APT on DRDO, again, this was unfortunately again attributed to China. Uh, it was an attempt to exfiltrate our missile guidance system documents, and as many of you might know, because this was public news, it was trying to essentially look into our S300 and S400 procurement details. Okay, so now let's come to the real world. So as of now, we have a kinetic war going on. Okay, uh, and we also have multi countries involved, unfortunately, because the target country has nothing to lose, essentially, when you look at it that way. So they are going all out. Okay, so how is this happening? Okay, so it is happening with SIGINT, HUMINT, OSINT, SIBINT, and okay, so I missed one thing in this, SATINT, which is satellite intelligence. So signal intelligence, human intelligence.
Sorry for interruption, but I would request you to wrap this up because we've already exceeded a lot of time.
Yeah, so I'm almost through with this. Uh, so we actually need this kind of tied up intelligence to, uh, survive a kinetic war. And obviously, this can only be done via all these intelligence put together. I'll just come to next and close this with something new. So, do you know who is the latest victim of the AI threat? Uh, just take a wild guess. The world's largest bank, the Fortune 10 companies, uh, the world's largest investment bank, the world's largest individual. No, it just happened a few days back. This guy. And here's how. Okay. So, number one, we have Israel's Mossad hacking into 15,000 CCTV cameras, which is ICS SCADA systems. And they actually tracked and analyzed the Supreme Leader's family for almost 6 months. They then exited foot on the ground from there, because obviously Israel was determined to attack. Now, once you don't have foot on the ground, you then rely completely on your SATINT, OPINT, and OSINT. Okay, so once they had done facial recognition, they were actually able to run entire patterns of how the bodyguards move, how the Imperial Guard moves, how they protect him in the residence, at the workplace. And a prediction analysis model was mapped out when he is going to be in that bunker. And basically, phase 5, this is when the strike was authorized and a Sparrow bomb was eventually dropped. So, I think in the interest of time, I mean, there is more to look at, but I mean, if I look at my time, I think I have overshot. What I like to do is, there is a lot more, but I'll rather move to questions right now. So, are there any questions for me?
Yes, sir. So one question is, so why are there very few agentic AI antivirus malwares being developed and they lag behind?
Okay. Great question. So there are a lot of agentic AI defenses that are being sold in the market today, actively under the tagline of machine learning, deep learning, etc. Unfortunately, they are not able to keep pace with the state actors. They are not able to keep pace with the speed of fake GPT, fraud GPT, and the likes, which are actually generating these payloads. So uh, there are products. I don't want to name any, but like I said, we want to talk about the bad part. So it's, as of now, not enough. You can have a layered defense. If I may just to answer that question a little bit better, uh, you can have you have to basically come at this level of maturity. Okay, this is where you can have actual defense in when you have self-healing defenses at an autonomous mode and optimizing mode. This is where you can defend against agentic AI threats. Otherwise, you are lying exposed. And this is a AI native SOC architecture, but this is futuristic. This is something that doesn't exist in today's world. Okay, so you need something like this to actually minimize. Again, I'm not using the word stop or prevent. To minimize agentic AI threats, you need so many layers, and such kind of product unfortunately doesn't exist today in the world. Okay, we consult with a lot of people, but yeah, we are still getting there in terms of maturity. Next question.
Yes, so the last question for the day is that what is the solution if XDR, CIEM, and SOAR is not sufficient?
Okay, so yeah, essentially you have to you need a mix of AI experts, ML experts, model trainers, model auditors, along with your SOC analysts, to work together. There is right now no system which can claim to be which can claim to give you full immunity in terms of agentic AI threats. Your orchestration is easily defeated by the fact that it is polymorphic. The dwell times are insane. It sits 4 months to 1 year without doing anything. So basically, when your EDRs have already done the learning, they already have identified that payload as an innocent payload. So the next time when the differential scan happens, it is going to ignore that file as an innocent file. Yeah. Can we take more questions?
Sir, I think we will have to end the session here.
Okay.
So, thank you so much, sir. We sincerely appreciate your expertise and the clarity which you have brought today. to the complex AI concepts. And I think your lecture has truly sparked new perspective and ideas. We are very grateful to have you. Thank you so much, sir, for the fantastic session. And thank you to the audience also. We'll surely meet you next week, maybe with yet another different topic. Thank you so much, everyone. Thank you, sir. Have a nice day.
Thank you all.